Hello, everyone. Welcome to the session on Azure Container Storage. So today we're going to talk about how you'll deploy and manage your storage volume with Azure containers. I know folks will trickle in a bit, so as folks come in, we will kind of, we'll make forward progress on our content, and then we'll do the Q&A. And last, I actually have my team here, Saurabh, who will be co-presenting with me. I'll give him the mic.
Hello all, I'm Saurabh. I'm a PM in Container Storage team at Microsoft, and I work at Azure's platform managed CSI drivers as well as Azure Container Storage Service. Thank you.
Yes, and that reminds me that I forgot about my intro. So this is where when you have tech issues, you can't really follow your original plan. So I'm Yuemin. I am Principal Program Manager from Azure Storage Team. I work on Azure Block Storage, Azure Disks and Elasticsearch, and also Container Storage. So for today, we are going to talk about how you will run stateful containers on Azure. And we will reserve Q&A time at the end, and definitely you can use Teams chat to raise your questions, and then we also have support from the joining on Teams, which they will answer your questions on the fly. All right. So as we can see that now we are having, talking about containers. So for us, container is the new VM. Containers has transformed from just a buzzword that I wanted to use containers as we see more customers really using it to modernize the applications or build their cloud native applications. So most of their journeys, or most of your journeys, started with stateless containers, where you first try out with running your websites on containers. But then as you build your expertise, or as you kind of accumulate your experience in using containers, you're starting to look at your core data services and how you'll be able to run that on containers. And this is where, when we talk to customers, they are telling us that, oh, when I'm looking at it from the data perspective, I'm running into several challenges. A couple of things that we hear from them as the typical pain points are related to existing solutions are built more for the IaaS-centric infrastructure and trying to retrofit it for the containers. So what do I mean by that? So if I take an example, in any cloud providers, you have your Kubernetes nodes and you are packing. Oh, sorry, is it too loud? Okay, great. Thanks for letting me know. In this case, when you're looking at it from the container perspective, you are increasing your density for your compute by packing a lot of pods into Kubernetes hosting nodes. Then when you're looking at storage, you do need to have persistent storage for your containers. Where today, most of the existing solution, how they handle it is that they have block storage solutions that is still attached to your Kubernetes nodes. And then going through this host attached, trying to front the storage into your pod. That means you will have a bottleneck on the disks to VM attach as what is the ability, what the maximum of what your AKS node or Kubernetes nodes is able to attach on the storage. You would only be able to front that to the upper layer. So from our perspective, we understand that this is not really the true scale that you're looking for containers. You wanted a solution where your storage can really match the scale out speed for your pod. Beyond that, as you're looking into running a large Kubernetes clusters, you wanted to leverage the portability and the flexibility of scheduling your jobs across different pods, and your pods can die and then come up easily from a different node. That means when you have a persistent volume, your data are there to serve your applications. Your persistent volumes need to also move quickly with your pod as your pod move from node 1 to node 2. So this is critical for enterprise mission critical applications to be able to deliver the availability targets you have. Lastly, on storage-wise, we have a lot of variety of different storage options, and we wanted to make sure that for containers, you can choose the storage option that is best fitted for your workload. So we wanted to give you the access to the comprehensive portfolio of the storage solutions that we have made available on Azure. Having that said, we would like to introduce our new service, Azure Container Storage. the industry-first platform-managed storage solution. So what is Azure Container Storage? In one word, it is a Kubernetes native volume orchestration and management service. So what it is not a new storage offering. So we're not introducing a new disk, a new file. It is a solution where it is a service where it's fronting different backing storage option that is available on Azure platform, either disks, ephemeral disks, Azure Elastic SAN, and we provide an experience for container use cases to best leverage these storage solutions that's available on our platform. You will continue to be able to use your favorite, Kubernetes tool sets to access, manage, create your PVs, create your PVCs, and manage your snapshots. This is where for Azure Container Storage, it is surfing on top of our block storage offerings, where it provides persistent volumes for read-write once scenarios. So this is where if you're thinking about running database workloads, you're running Cassandra workloads, this is a good fit for that. Beyond that, we want to give you the cost efficiency for containers by default, meaning that we don't want you to do additional level of optimizations after you kind of do your initial after you did your initial containerization of your application. Beyond that, if you're really thinking about running your core data services on Azure Container Storage, you need to make sure that on both scale, availability, and also on the data protection aspects, we give you the enterprise level quality support. Lastly, and something which is where it comes back to one of the pain points we talk about, is that we wanted to make accessing storage very easy for you through Azure Container Storage, where you will have a consistent volume management solution across the different storage backing options we offer. So here you can see a diagram on how we see that the Azure Container Storage fits into your architecture. So Azure Container Storage is deployable as a AKS cluster extension. So it's a microservice that runs in your AKS clusters. And you'll be able to choose the different backing storage options for it. Today, for block storage-wise, we have disks, and you can access it through disk CSI driver. We added 2 more storage offerings into this edition, Azure Elastic SAN and ephemeral disks. Key benefits for Azure Container Storage. Number 1 is on the TCO. We project you will be able to get roughly 15 to 20% cost saving on your storage with Azure Container Storage. And what is best is that the bigger storage footprint you have, the more savings you'll be able to gain from this new service. Regarding of scale out and scale up, I would strongly recommend all of you who are staying for tomorrow to be in Mark Rusinovich's session. I think he's doing a session on Inside Azure Architecture. He will be giving an amazing demo on how you'll be able to scale out your AKS cluster with Azure Container Storage. So you'll be able to see that how rapidly you'll be able to scale out beyond what is the existing limits, and then being able to really get to a point which you're looking for running large-scale enterprise-grade applications on AKS. So I'm going to touch a bit about the different container storage, backing storage options. So Azure Disk is what you have today. So it will continue to be supported in Azure Container Storage. This is where you will have granular control of your different storage SKUs. You can pick whether it is Premium SSD v2, Premium SSD for the different SKUs of your choice, and manage the configurations and placements from that. It is very well suited for tier 1 database type of workload. The 2 new offerings which we added are the ephemeral disks. This is where we hear from customers. They wanted to use the locally available storage that is on the AKS node. So for workloads like Kafka, where the application have the replication of the data, or for some of your workloads you just need a scratch space, you do not need durability of your storage, you can use the storage that is made available on the AKS nodes. So in the preview of Azure Container Storage, we support NVMe drives, which is available on the L series VM SKUs if you are deploying your AKS clusters. Then we have Azure Elasticsearch. This is one of the newer block storage offering. If you're not familiar with this, two unique aspects about this offerings. Number one, it natively support iSCSI protocol. So you have remote block storage protocols into the storage services. So it fits very well in the containers models, which you can use iSCSI for fast attach and detach. Second one is about the provisioning and dynamic sharing model for Azure Elasticsearch. So basically, you provision your storage on the pool, and then it's being shared across the volumes under that Elasticsearch. So for both of these three storage solutions, it is available in Azure Container Storage as preview. So when you are creating a container storage pool, which later Saurabh will show a quick demo on, you'll see what is the process, and we offer a consistent experience for you to use Azure Container Storage against different backing storage options. So I've talked about what Azure Container Storage is. You may be wondering, so what is so unique about the service? What is it different from the existing CSI driver that we have? So Azure Container Storage, we actually take a very different approach. So first of all, on how this service is being packaged or run into your AKS environment is different. So it's going to be deployed through Arc extension as a microservices, which runs your AKS environment. You can specify which nodes you wanted to run the services on, depends on how you wanted to allocate your node for compute or storage purposes. I'm going to drill into a little deeper onto two kind of architectural design that we have chosen to be able to give you the benefits on the scale and on the cost efficiency. First, I wanted to highlight is that with Azure Container Storage, you are, instead of doing a host mount of your persistent volumes, we're basically leveraging the service to front an NVMe over Fabric endpoint so that we'll be able to directly guest mount your persistent volumes into your pod. That's where we're able to scale independently from what is the host mount for the underlying, hosting node, and being able to offer you very fast attach detach by doing NVMe over Fabric mount and unmount through the data path, so that you'll be able to have your PVs moved across the node as your pod moves, and significantly reduce the failover times that you're seeing. Second is regarding of the cost efficiency. So if I use disk as an example, so today, if you are deploying through CSI, you have single PVs backed by single disks. It works very well for models if you want a dedicated storage, IOPS and bandwidth being allocated to that persistent volumes. But we also see that in cases when you have a clustering of the workloads, your maximum IOPS and bandwidth for individual volumes are pretty high. But then when you look at the average across the entire AKS cluster, your average is kind of pretty low. So we constantly hear from customers as, I'm always over provisioning for my performance. I'm not using it as much as I wanted to. So that's where what we're able to do is that with Azure Container Storage, you can deploy one disk, and then we can pack multiple persistent volumes into the single disk. So here we label it as volume, which is kind of a new logical concept, where in this case, let's say you deploy a 1 terabyte disk, you can pack 100 GB persistent volumes where you will share the IOPS and bandwidth on that disks. And by doing so, if for your workloads, if you don't expect all of your persistent volumes to kind of burst at the same time, you'll be able to gain more benefit through this dynamic sharing of your resources. So hopefully by now you get a good understanding of what Azure Container Storage is. And we always believe it is better to see it in action. So I'm going to have, Saurabh, which will show you how easy it is in initializing Azure Container Storage services and create your first persistent volume using Elasticsearch.
Thank you, Yuemin, for introducing us to Azure Container Storage Service. Now I will get into the demo on how you can use this offering, and the backing storage type that I will be using will be Elasticsearch. So as Yuemin earlier mentioned, that we have 3 types of backing storages, and the first one is Elasticsearch that I will be using. The other one is Azure Disks, and the third one is ephemeral pool. So I will first get into the architecture setup of our demo today. So first we will deploy Azure Container Storage Service on an existing AKS cluster. Then we will create a storage pool of type Azure Elasticsearch, and then we are going to create a persistent volume claim and mount persistent volumes on a pod. For installing Azure Container Storage on an AKS cluster, we will have to provision managed identity on that AKS cluster's managed resources. Then we are going to create a storage pool where we'll be providing the type of storage pool, which is Elasticsearch in our case. Then we are going to create a PVC and mount persistent volumes to a stateful pod. Now I will get into the demo. So as you can see here, we have an existing cluster called AC Store Demo Cluster. It consists of a node pool having 3 machines and 4 cores. Now we are going to connect to this cluster on Azure Cloud Shell, and we'll make sure we have right credentials to operate on it. Once the connection is successful, we are going to label our node pool. This command labels our node pool to the IO engine of Azure Container Storage. We can also cross-check this on Azure portal. This step is completed. Now I'm going to show that the node pool is labeled on the Azure portal. Here we can see that the node pool has been correctly labeled. Now I'm going to move to the step involving managed identity. So I will click on access control and I will provide contributor role to the managed identity on this AKS cluster's resources. I will select managed identity. Under user assigned managed identity, I'm going to find my cluster's agent pool resource. We have successfully assigned contributor role to the identity. Now I'm going to install the extension on an existing AKS cluster, and I'm going to use this extension command for that. It typically takes a few minutes for this to get installed, but I have fast forwarded this for the purpose of this demo. As we can see, our extension has been installed here. We can also cross-check the status of our extension using this command. So here we can see that the type of extension is Microsoft.Azure Container Storage, and the provisioning state says that it has been successfully installed. Now we are going to create the storage pool. For that, I'm pulling up the YAML file for storage pool. Here we have provided the name of the storage pool, and the type of storage pool is Elasticsearch, and I'm requesting a 1 TB storage for this storage pool. Now I'm going to use the kubectl command to create this storage pool. Our storage pool has been successfully created. We can use the describe command to check the status of this storage pool. So here you can see the spec of the storage pool, and also the status that the storage pool is ready to use. With the creation of this storage pool, Azure Container Storage out of the box creates a storage class for you. So we are going to take a look at the storage class that is created for us. The name of the storage class that the service will create will be AC store hyphen the name of the storage pool that you just created. In this case, it is AC store managed. Now we are going to create a PVC. So let us have a look at the PVC YAML. Here we have chosen the access mode as read write once, and we have provided the storage class that we have just saw. Now we are going to use the kubectl command again to create this PVC. The PVC has been successfully created, and we can see the status of our PVC. Now the PVC is ready for us to create a pod and mount volumes to it. So I'm going to create a pod. Here's the YAML for the pod. In this pod, we are going to use a FIO pod, which is a flexible IO pod for testing and benchmarking purposes. And I'm going to provide the mount path as well here. Now we will create this pod. And we are going to execute the FIO pod for us. As we can see here, the processes have started running for us. That means that our pod has been successfully deployed and volumes have been created. So this is how you can provision volumes using Azure Container Storage. Now, if you want to learn more about this service, you can refer to the links here. As well as if you are eager to try out this service, you can fill out our survey. We have a link here. And also, if you have any feedback for us, we'll be eager to include that in our future roadmaps. Thank you. And now I will hand it over back to Yuemin to talk about enhancements to existing storage options that we have.
Thanks, Saurabh. So, right, Saurabh has demoed Azure Container Storage. So we would encourage you all to sign up and then give it a try and share with us the feedback. So while we innovate on Azure Container Storage, we understand it's still very important for us to focus on evolving our existing CSI driver implementation, as majority of the customers and many of you may be already using it. So we wanted to continue to make sure that we give the first-class citizen experience, as whenever there's any backend storage enhancements, we make it available for container scenarios. So on the disks aspects, we do have a disk CSI v2 driver, which is in preview. So this is our attempt to kind of address the failover challenges, long failover time challenges you have today by using shared disk to have the disks attached on multiple nodes, so that when you're actually doing a failover, you'll be able to save the attach and detach time and achieving fast failover. Beyond that, I'll highlight two of the more recent enhancements on the disk aspects. One is on the premium SSD v2. So this is one of the new block storage offerings that we introduced. It will provide you the best price performance. We suggest using it for any of your general purpose kind of database workloads. So it's able to provide you some millisecond latency at a price and performance which is better than our existing general purpose premium SSD SKUs. So in the past few months, we actually expanded the regional footprint across multiple Azure regions. And we do see that for if you have any workloads that previously you need some millisecond latencies and you are not able to onboard onto Azure, this will be a block storage offerings that you should consider and give it a try. Beyond that, we wanted to highlight about Azure's support of a zonal redundant disk. This may not be news for many of you, but we do see it is a perfect fit for the AKS scenarios when you're looking for a highly available architecture. Because today, as you're deploying an AKS cluster, you can choose the number of zones you wanted to spread your clusters over. But when you handle on your compute, what about your storage? How are you going to handle your data replications across the zones? So Azure Zonal Redundant Disk is a unique and differentiated offering only available on Azure, where we will be synchronously replicating the data across all the 3 zones. What is even better is that compared to you manage your own replication through a mirroring disk on another zone, ZRS disk only costs around 50% more than the LRS disk. So it's even a cost-efficient option for you to have a HA architecture. So besides the disks, which is our offerings for the read-write only, I do wanted to touch upon on our shared storage options. So this is where we will talk about Azure NetApp Files, Azure Files, and also Blobs, where it's ranging from a more high-performance end to the more cost-efficient and well-suited for capacity-intensive solutions. So for Azure NetApp Files, a couple of our focus are on how we will be able to offer this high-performance solution to you in a good price point. So what we are seeing that for many of the AKS customers, you wanted to try out Azure NetApp Files, but for your data services, your initial footprint is pretty small. So a common feedback we hear is that, oh, you wanted to have a smaller footprint of the Azure NetApp Files to cater on your existing workloads and then only grow when needed. So this is where we have a preview of a 2 terabyte capacity pool. So basically we're bringing down the entry size for ANF from originally 4 terabyte to 2 terabyte. And beyond that, we're also supporting a sub-volume, which is basically similar to the concept we have Azure Container Storage, is that you'll be able to place sub-volumes, which is kind of carve out smaller storage unit within your ANF to serve for read-write only use cases. Then we'll pivot to Azure Files, which is the general purpose file solution that is well fitted for scenarios like DevOps, CI/CD, container management systems like WordPress. On this note, for files, one of the key asks we hear from all of you is about the performance. So how can I actually maximize the performance I'll be able to get from a files from a single pod or a single client? So we recently released files NConnect support. So what is NConnect? Is basically a Linux mount option that we support where you can use more TCP connections to drive your traffic to the backing file share. So in this note, we did some performance benchmark. We are seeing roughly you can get a 4x boost from a single client to be able to maximize what is the IOPS and bandwidth you can get on the file share. So we do have a very detailed documentation on NConnect, which actually have a comparison regarding of the performance of using different NConnect options versus not using this. So this is something I'll strongly recommend you to check it out. If you're already using files today, this could be something that you can easily, pick up and then enhance and get a performance boost on your existing use cases. Last but not least, we have blobs. So for blobs wise, this is our approach for the object storage. Here we are talking about the blob CSI driver. We also are working with the open source community where we have Cozy driver, which is container object storage interface that is in alpha version. So if you're looking into looking at more object storage centric scenarios, feel free to check out that. But on the blob CSI drivers perspective, we are seeing that for customers who have data already pushing into blobs and wanting to use run a container workloads for doing the data analytics or doing the image processing or video processing against a backing blob storage. This is where we see it's a very good fit here. So from a blob perspective, we added support for the storage classes for premium blobs. So if you're looking at driving higher Mbps bandwidth from your backend storage, premium blobs could be something you can consider. Beyond that, we also made private endpoint support for blobs available for the AKS environment. All right. I wanted to open the floor for question and answers. I'm going to put the roadmap slide here, so I'm not going to drain into this. Feel free to read it through, and we can use this Q&A to address any of your questions regarding of the new services we have, our existing services, and if any questions you have regarding of what are the upcoming new capabilities, enhancements that we have on our roadmaps. Feel free to raise your hand here in person, or if there's any questions on the chat, I will read through ones that my colleague has not yet addressed. Questions? No? It could be anything. Storage, container storage, AKS cluster. Sorry? Oh, very good question. I knew I'll get questions that I don't get. I did not prepare for. So for Lustre, I think Lustre files, I believe we recently get to GA. So public preview, I think we are close to, that is where, from a Lustre use cases perspective, for folks who are not very familiar, it is a very kind of parallel file systems, which is very well fitted for some of the more, analytics type of workloads. So for Lustre, if you go to our AKS website, we do have a CSI driver support and support for Lustre scenarios. We did not explicitly put it here because we think from a Lustre perspective, it is very targeted for specific use cases. We see it more as for customers who are using Lustre today, either on-premises or on their private data centers, and wanting to have a more like-to-like experience. And that's where, on Azure Wise, we introduce Lustre a file system so that we give you native support on cloud. So is your question, if you wanted to know more about what is our plan for Lustre and the timeline, I'm more than happy to connect to the PM to give you more insights. So just making sure folks on the call could also hear it. So I'll just repeat the question. So the question is regarding for the Azure Lustre files and for the CSI AKS integrations. Is there any specific limitations? So I don't know on top of my head on any specific ones worth calling out, but I will always recommend in referencing to our official doc. What I will do is that I think we'll paste the link. I think I have colleagues online. We'll paste the link to the Lustre documentation that has the callouts on the pseudo scenarios and if there's any limitations with the current where the product is. And like like Sarah mentioned, if there's certain capabilities or features that you felt is not yet exposed through the CSI driver, you could add it there. You can, sorry, I got distracted. If you have any feedback on the capabilities we don't support right now, feel free to shoot us an email on azcontainerstorage@microsoft.com. Okay. Any other questions? Very good question. So the question I got is that for Azure Container Storage, is it only supported for AKS or does it support for other container solutions, for example, like Azure Container Instance and all that? Right now in the public preview, Azure Container Storage only supports Azure Kubernetes Service, so AKS only. But this is definitely something which we are looking into. So from a directional perspective for Azure Container Storage, we wanted it to be the container native storage that served different Azure container solutions. So it would be, AKS, you have ACI, and then you also have deployments on the edge environment. So right now in public preview is only on AKS, and then this is something which we are looking into evolving in our future iterations. And if any of you have, let's say, customers that you felt they will be interested on, let's say, partnering with us in looking at the edge scenarios or more hybrid use cases, do reach out to us. And we wanted to kind of get your feedback so that we evolve the product in the direction that will fit what customer needs. Okay. No other questions? I can, yeah. So the question I got is that for Azure Container Storage, can you mix and match the different backing storage option, or you have to pick one? Very good question. So for today, the top level resource you create for Azure Container Storage is called Azure Container Storage Pool. At that, you do need to pick one backing storage, whether it's Elasticsearch, whether it's ephemeral disk, or whether it is Azure disks. And for one AKS cluster, you can have multiple container storage pools. So the mix and match happens on that level. But to your question, if you're looking, I do want to, this is a very interesting topic. So when you're saying on a kind of mix and match, is it more as you're looking for a tiering solution, or you felt that from a simplicity of a management perspective, you wanted to have one entity and place your PVs differently on the need? I see. I see. So I think that's a very interesting point. So I think on using it in choosing PVs for different scenarios, for example, stretch space or not, I think you will be able to achieve that by deploying different storage pool. But specifically, if you're looking from a tiering perspective, that I think capability is not there. But I think this is very interesting input. We should look into that, because I think if you look at the storage services, some of our storage services itself natively support tiering. Maybe we should discuss whether this is something which it should happen on the storage services, or there's something we can do some orchestration on the container storage solution. But that's a very good point. Okay. Any other questions? Sorry. Yes. Repeating question from the audience. Yes, I'll do that. I'll make sure that I will repeat the questions. Any other questions? We have 5 more minutes, or I can, if anyone on the joining virtually, you wanted to unmute and ask your questions, that's perfectly fine. If not, I will also kind of go back to the list and see if there's any unaddressed question in chat, and we can read through and go and address it. The question I get is that, is there any roadmap for rolling in Azure NetApp files into Azure Container Storage Service? Right now, from a roadmap perspective, I think my roadmap slide went away. I'll come back. So in the near term, when I say near term, I think in the kind of the 6 months time frame, we don't have plan on that yet. But from the Azure, if you look at it from Azure Container Storage, we are starting with integrating with different block storage options. So all that you can see that disk, ephemeral disk, or Elasticsearch, these are all block storage options. Well, we wanted to kind of go with a more crawl, walk, run. We wanted to make sure that the entire experience for the block storage is very well polished and have a nice end-to-end experience, including BCDR, native HA support, volume mobility across clusters. So we wanted to get it there. Then we were looking into kind of expanding it for the shared storage options. So that's how we are looking at it in planning for our roadmap. So to your point, I think we understand from customer perspective, adopting a new services, they wanted to kind of use that to fund all the different underlying, storage options to have a unified experience. And then from our perspective, that is something which we will look into, but I think it's not right now on our roadmap. Okay, questions. I'm going from last up. Is that the first question on chat is that where can I read more details on the latest improvements on Azure Files and Connect performance boost? I think I'll let folks on the call share the link for Azure Files and Connect. There is a specific document which talks about how you will leverage and connect. I think we'll paste it in the chat. Okay. The second one, I think there's the one which has been addressed, so I will move up. I think my colleagues on the call is doing an amazing job in answering the questions. There's a question about what's the best config for offsite backup. This is a very big question. I think what we would want to, maybe we'll need to connect with you. If you don't mind, shoot us an email on AZ Container Storage. I think we can look into this. Depends on what are the scenarios you're looking for. So for example, like we have backup, take Azure Backup as example. It has aka.ms integration for disk CSI in public preview. It will go into GA soon. But when you ask this question is on kind of an offsite backup, my understanding is that you may have your containers environment running on premises or some environment, and you're looking into doing a backup on cloud. This will depends on what is the on-prem settings, and maybe I think either Azure Backup can provide some coverage, or some of our third-party backup partners will come in helping on that. But feel free to email us on Azure AZ Container Storage so that we can discuss this in more details. It's a little bit challenge for us to give a recommendation without knowing the specific use case. Let's move up. I think there's a question of what is the IOPS of the ephemeral disks. So for the IOPS of the ephemeral disks comes with what is the aka.ms kind of the VM SKUs that you choose. In our preview for Azure Container Storage, we support NVMe for L series VM. So if you wanted to know what is the NVMe drive, what is the IOPS it can deliver, you can refer to the VM SKU page. So if you go and search, like for example, L series, you can find L series VM page, and then underneath that you will have a table which lists out what is the NVMe drive IOPS and bandwidth you can deliver, and what is being called out on the NVMe drive IOPS and bandwidth target is what you would expect to get when you are using it for the container storage scenario, if you use ephemeral disk as the backing storage. I think I am right on time. I also see the next speaker coming. I happen to know our next speaker. So I will wrap up. So if you, like I mentioned, I will ping on our team's email address in the chat. So if any of your questions that has not been addressed in the chat, feel free to send us an email and we will respond to that. Thanks everyone for attending. Hope you have a great build experience.